Now, we will start this triaxial test on cohesive soils UU, CU and CD test. So, we will explain it step by step. EU test for cohesive soil, remolded or maybe compacted. Now, take a soil sample. In isotropic condition, sigma 1 is equal to sigma 3, which is equal to sigma c, and pore water pressure is equal to 0. Delta sigma 3 is your confining. It is just you applied, you can say applied pressure. That means with no drainage, this means U is equal to delta sigma 3 confining pressure. That means delta sigma 1, this is your deviatoric stress, which will be effective stress on plane AA and delta sigma n prime is equal to delta sigma n minus u, which is equal to 0. This will be carried by soil cohesion. So, with sigma prime effective stress sigma prime is equal to 0, that means friction in terms of total stress, it is 0. That means S is equal to C. Now, if you look at this is my UU test, earlier we have finished for cohesionless soil. In triaxial test, UU test unconsolidated, undrained, means drainage path is closed. If you look at there, this is my soil sample, typical soil sample. Initially what will happen? Confining pressure has been applied, all round confining pressure has been applied. So, this will be your confining pressure, let us say delta sigma 3. In isotropic condition, what is isotropic conditions? That means sigma 1 is equal to sigma 3, which is equal to sigma c. In isotropic conditions, pore water pressure is equal to 0. So, delta 3 is your confining pressure, it is applied. How this shear strength means triaxial test has been conducted? Initially, the soil sample has been put it in the triaxial mold. Inside that triaxial the pressure delta sigma 3 all round confining pressure is applied. Once the all round confining pressure has been applied, then with this pressure you can say that the consolidation may be applied with your isotropic conditions, or consolidation has been done without also isotropic conditions. So, I have taken the failure envelope of the soil sample in these directions. So, here once after the consolidation, means there is no consolidation, you have to apply for shearing, means delta sigma 1 is your deviatoric stress, that is your delta sigma 3 plus delta sigma. This is my stress applied in vertical. If I say this is total my sigma 3 or delta sigma 3, this plus delta sigma will be my delta sigma 1, delta sigma 1. Now, what will happen? That means delta 3 is your confining pressure, delta 3 is your confining pressure applied, as it is unconsolidated, undrained, that means there is no drainage. What will happen? U is equal to delta sigma 3, whatever the pore water pressure, it will be because of your applied confining pressure. The moment you apply your deviatoric stress delta sigma 1, that is your effective stress on plane AA, effective stress on plane AA, what will happen? Delta sigma prime effective stress is equal to delta sigma n minus u, which is equal to 0. So, what will happen with this term? What will happen? Friction in terms of total stress, friction in terms of total stress is equal to 0. That means S is equal to C plus sigma tan phi. So, this will be 0, then S is equal to your C, that means your shear strength will come in terms of C. Now, the diameter of Mohr circle is unchanged by pore pressure, but origin of circle is shifted to left by pore pressure U. If you look at here, it is unchanged, but this origin has been shifted from here to here in terms of U, in terms of U. U is your pore water pressure. Now, for normally consolidated, apply and pore pressure what will happen if sigma c less than P0, that means it will be negative pore water pressure. Sigma c is equal to P0, U tends to 0. If sigma c consolidation pressure is greater than overburden pressure P0, then your positive pore water pressure is developed. Negative pore water pressure will develop when sigma c is less than P0. That means when the consolidation pressure is less than P0, what will happen? It will try to take the water inside. So, negative pore water pressure will be generated. When sigma c is greater than P0, positive pore water pressure, that means pore water pressure built up inside the soil. So, it will show that positive pore water pressure will be developed. When sigma c is equal to P0, that means pore water pressure tends to 0. Now, next part is your consolidated undrained test CU, that is your CU test. CU test means consolidated undrained test. That means consolidated undrained test means consolidation will be there. During shearing, this drainage valve will be closed. That means after consolidation, shearing will be done, means in undrained conditions, particularly in undrained conditions. Now, if I draw the diagram in two conditions, one is your isotropic conditions, other is your anisotropic condition. In isotropic conditions, that means consolidation under cell pressure sigma c, under cell pressure sigma c, it is not stress as in situ. Now, second is your consolidation under combination of cell pressure, consolidation under combination of cell pressure, that means sigma c, that means that is your cell pressure plus additional vertical pressure. Additional vertical pressure sigma 1 is equal to sigma c plus delta sigma 1. This is your additional vertical pressure it is says this is your anisotropic condition. and this is truly in situ condition look at these two conditions. CU test is your consolidated undrained, that means the soil sample has been first allowed to consolidation, then after consolidation is over, then the shearing will be done in undrained conditions, I have made two conditions, one is your isotropic, another is your anisotropic. In general, what will happen in laboratory, the consolidation has been done by means of all round confining pressure or cell pressure sigma 3. That means what happened, initially the soil sample you apply, first the soil sample is there, go for saturation, once its saturation has been achieved with your B parameter checked, then you go for your consolidation. The consolidation has been done with only whatever the cell pressure applied, is applied with by means of cell pressure application, the consolidation has been done. Once you open your drainage valve or by measuring what is that change in water level, that also standard way you can find it out your consolidation under the cell pressure. These conditions, particularly consolidation under cell pressure, because the cell pressure around these three sigma 1 and sigma 3, because this is cylindrical shape, sigma 1 and sigma 3 are same, that condition is called isotropic. But what will happen, it is not truly reflecting the soil sample. Suppose this is my field conditions, suppose soil sample is collected at a distance or at an height of z from the ground surface. Once the soil sample is there, what will happen, this has both vertical as well as lateral pressure, this is your sigma 1 sigma 3. It is not always that sigma 1 will be always sigma 3 or which is equal to also sigma 2. In that condition, stresses in all round, if it is same, in that condition it is called isotropic, but which is not true in case of in field conditions. That means to simulate the field conditions in laboratory, what will happen, consolidation under combination cell pressure. Under combination cell pressure means first you apply your confining pressure or maybe cell pressure, let us say that is sigma 3, let us say sigma 3 is equal to 1 kg per centimeter square. Apply the confining pressure all round. I will show you a video maybe after this test completely, this shear strength part is there, about this equipment I will show maybe some photographs or video. So, let us say confining pressure sigma 3 1 kg per cm square has been applied. Then once this kg per cm square has been applied, you apply additional vertical pressure, vertical pressure that is your sigma 1, which is equal to delta, means additional vertical pressure you say delta sigma 1, additional vertical pressure say delta sigma 1 you apply. That means what will happen, sigma 1 all round confining pressure is your sigma 3, what will happen sigma 1, earlier in isotropic sigma 1 is equal to sigma 3. In that case, because of additional vertical pressure has been applied, so sigma 1 is equal to sigma 3 or sigma c plus delta sigma 1, that is your additional vertical stress applied. So, in this case sigma c, or we can say that sigma 3 plus sigma 1, that is your sigma c plus delta sigma 1, that represents your anisotropic conditions, and that will truly represent in situ conditions, your in situ conditions whatever is there. That means in general, once again I am repeating, in general, in consolidated on drain test, there are two types. One is your isotropic conditions, another is your anisotropic conditions. Generally in laboratory, isotropic conditions has been applied for your consolidation. In that case, all round confining pressure sigma 3 maintain constant. With this all round confining pressure, the consolidation has been achieved. But in case of anisotropic cases, means additional pressure after all round confining pressure sigma 3, additional pressure sigma 1, that is equal to sigma c plus delta sigma 1, additional pressure will be applied. So, that means sigma 1 will become sigma 3 plus delta sigma 1. So, this will be your anisotropic conditions, that means stresses in x and y directions are different. So, that will truly represent in situ conditions. That means, if I take a soil sample below this ground surface, sigma 1 is not necessarily that equal to sigma 3, because what will happen, sigma 3 is equal to always kind of k 0 sigma 1. So, definitely sigma 1 will be different than your sigma 3. So, to achieve that conditions, anisotropic conditions should be applied in the laboratory for your consolidation. That means, before starting your undrained conditions hearing for consolidation, anisotropic condition to be applied in the laboratory. Now, let us draw the basic diagram of void ratio and log P. There are two graphs I am drawing, one is your E versus log P, other is your delta sigma 1 versus stress versus strain, you can say stress versus strain. Let us start explaining this first conditions, void ratio E versus log P. Under normal, it is a for this graph I draw it for particularly normally consolidated clay. Under normal field condition, soil consolidate under path A, B and C, A, B and C. A, B soil consolidate under path A, B, C. So, means under normal conditions soil consolidate under path A, B, C. So, present status of the sample, if I take a soil sample in the field, as I said in the field condition, as it is a normally consolidated clay, that means this consolidation process is in underway. So, at an height h or z. So, once I take the soil sample, means soil sample point B, that means present status the sample of the soil. Once you say that at a distance h the soil sample is there. So, the status of the soil sample represent the point B. It represents point B. So, corresponding to one overburden pressure P0, corresponding to one overburden pressure, this is from B status, you can say that corresponding to one overburden pressure P0. P0. When sample is removed, that means the moment the sample is removed from the ground surface, as it is a normally consolidated soil, as I said, the present state of the sample is say at point B. So, corresponding to your overburden pressure P0, it may be here, it may be here. So, the moment sample has taken out from the field, it lost its overburden, it lost its overburden. Once it lost the overburden, what will happen? Without overburden pressure, sample will try to expand, that means this expansion is your BD. Once you take out, this is at the field condition, then once you take out the soil sample from the field, what will happen? The sample will lose its overburden pressure, so it will try to expand, that is your BD. That means pressure is lost and hydrostatic pressure condition are changed. So, line BD is that conditions which represent sample expansion due to loss of confining. This is your, you can say, sample expansion due to loss of overburden. Sample expansion due to loss of overburden. Then dB, what will happen? dB is your after sample placed in triaxial. What will happen? At this condition, this is your field conditions. So, BD is your sample has been taken from field, that means it lost, a sample expansion will occur due to loss of overburden. From D to B prime, that means AB, if I write it, B is your status of soil sample, in field. Then BD I have written, this is your expansion due to loss of overburden, then dB prime will come the moment you put it inside your triaxial, because of confining pressure, it will again recompression will start D2 B prime, this is your D2 B prime. So, what will happen from bringing this sample from field to making in the laboratory in the triaxial test, this will be, it will go from, to regain its original position, it will go from B to B prime, it will go from B to B prime. If I have taken here B to B prime, what will happen? So, B prime is nothing but is your degree of disturbance. Degree of disturbance, or it may be because of your creep. Now, look at this once again, I am saying once again this explanation is there. ABC for normally consolidated soil, ABC for normally consolidated soil, this is your normal, ABC is your normal consolidation graph. That means normally consolidated clay means the consolidation is going on. Let us say B is your point where the sample, it represents status of present soil sample. Then what will happen, the moment you take the soil sample from the field to laboratory, it will lose, it will lose the overburden. Then sample try to expand, the sample expansion because of loss of overburden, that is your B, that is B is here BD. Then the moment you put the soil sample inside the triaxial, what will happen, because of confining pressure sigma c, it will become again, it will recompress from D to B prime. This amount, this particularly B to B prime is your general disturbance of sample from field to laboratory, and it represents your creep. Now, if you look at here, now these are increase in stress, means stress versus strain. One I have drawn for brittle, other is your for low sensitive soil, that is for particularly residual part, means after peak this residual part will merge with your low sensitive soils, or you will get a residual, means strength remains after your peak. Now, if I draw this graph represents about your sample disturbance. Now, come back to it in terms of residual, means CU test in terms of residual and peak. If I draw it, Now, Mohr circle for residual and peak, if you look at this diagram, means this for this particularly what will happen in stress versus strain in consolidation test, CU test. So, it will go reach achieve a peak, and that peak we have considered as a failure, peak failure. So, sigma 3 is equal to nothing but is your P 0, it will start here, then here it is coming, this is your confining pressure applied, here it is coming your peak, that means that is your sigma 1 where it is coming this point, and this gives Mohr circle in terms of peak failure, Mohr circle in terms of peak failure, this represents C, this represents phi, sorry, this represents phi, and this represents C. Now, if I want to draw for residual strength, the same confining pressure it is there, but if you look at here residual strength, the strength here it will be somewhere else, the peak will be somewhere else, say delta sigma 1, and here it will be somewhere else, say delta sigma 1. If you compare both, that means delta sigma 1 for peak is greater than delta sigma 1 residual. So, what will happen? The moment you draw in terms of residual, what will happen? Delta sigma 1 peak for residual, it will shift slightly away from your peak, but sigma 3 is constant. So, what will happen? This peak, if it is like the shear parameter, it will be become slightly flatter side. The graph here, the curve here, you will look at here, it will come slightly flatter side. What will happen? This is for your C residual, and this is your phi residual. Because of P, this C value will be high, phi value will be high, and because of this it will be phi residual and C residual. So, while designing what parameter you need from consolidated on-drain test, CU test, means if you want for peak, then you can use this C and phi for peak in design. If you want for particularly phi residual and C residual, so you can take this value of residual value where you can utilize for your design. So, this is all about means brief discussion, particularly consolidated on-drain test, how this behavior, how it represents with this field conditions, then what will happen if it is a residual you want or peak, this has been explained. Next step is your consolidated drain test.